Hello everyone, today we're going to be going over some organic reaction pathways. Right, so let's start with looking at some alkanes. Okay, so we're going to start off by looking at some alkanes reactions. Most of the reactions we look at with alkanes is a substitution reaction. Okay, so I'm going to put in here alkanes and then a little bracket and then just substitution, because that is the main one that we will be looking at. Alright, so let's go through an example now. We'll actually talk about how haloalkanes are formed, which is alkanes that have a halogen attached to the carbon chain instead of a hydrogen. Right, and that is formed through a substitution reaction. So let's go through that a little bit more now. Okay, so let's have a look at this one here. We can see we've got a, so here we have an alkane, we have methane, and it's being reacted with Cl2. Alright, so it's being reacted with chlorine. So this chlorine here, this part here, this is actually the halogen. So that is the halogen there. Alright, so we have an alkane coming together with a halogen, and that produces a haloalkane plus HCl. Okay, so this is an example of a substitution reaction. Why is it substitution? Well, because we have a atom that is being substituted out for something else. So what we can see here is the chlorine is being switched out. So what's going on is these two are actually switching. So the hydrogen and the chlorine are being substituted out, or they're switching places. And if we look over here, we can see we have a chlorine instead of a hydrogen, and we have a hydrogen instead of a chlorine on this side. So that's a substitution reaction there. Alright, so this is the structural formula for this reaction. We also might be given just the words or the abbreviated worded chemical equation, which would look like this. So this is CH4 plus Cl2, and this produces CH3Cl plus HCl. Okay, so these two here are exactly the same. One is just got the structural diagram, so it's got those bonds being shown as well. And the one below it just has that abbreviated molecular formula, just looking at the symbols. Okay, both mean exactly the same thing, and they're both an example of a substitution reaction. Alright, so that is how a haloalkane can be formed from the reaction between a alkane and a halogen. Alright, so it shows an alkane becoming a haloalkane. Okay, so that alkane is reacting with a halogen, chlorine. It's coming together via a substitution reaction, switching places, and becoming a haloalkane. Right, so it's going from this to this here, alkane to haloalkane. Okay, that's substitution reactions. That's one type of substitution reaction. We will now have a look at some other types of substitution reactions as well. Okay, so we have these two species here, two alkanes, alright, two haloalkanes. We have CH3 and bromine, which is actually going to be bromomethane. Okay, so we have bromomethane reacting with, this is actually sodium hydroxide. So So the reaction is actually a haloalkane. In this case, it's bromomethane reacting with sodium hydroxide. But because the sodium is typically not involved in the reaction, it's more of a spectator ion, so it doesn't participate in the reaction. We're just going to focus on this hydroxide here, because it's a reactive species. So what happens is, focus on this first one here. It's a substitution reaction. So what we looked at before, the bromine and the hydroxide, we're just going to switch places. So, same thing as before. These two are just going to switch around, and we can see we have CH3 with that hydroxide group, and then also plus the bromine there. So we've gone from a haloalkane on this side to actually we have an alcohol now, which is a 1 carbon alcohol, so it's methanol. Alright, and a bromine atom as well. So that's an example of a substitution reaction with a haloalkane to produce an alcohol. Alright, the reason why it's an alcohol is because of this OH group here. This OH is a functional group of an alcohol, so it's gone from a haloalkane to an alcohol. Hopefully that makes a bit sense. So the substitution reaction here, we have a haloalkane being reacted with ammonia. NH3 is another way of referring to ammonia. It means the same thing. Okay, it's a substitution reaction. So these two molecules switch places. We have CH3, NH2, which is now actually an amine because we have the NH2 group on the end of that molecule, which takes it from a haloalkane to an amine. Alright, and then we also have the hydrogen and the bromine left over as another product. Okay, so key things to note from this reaction is the first one shows a haloalkane to a alcohol. Okay, and that second reaction is an example of a haloalkane to a amine. Alright, and they're both different forms of a substitution reaction. Okay, so that's pretty much everything for alkanes. Now we're going to have a little more of a look at alkenes. Okay, so now we're having a look at alkene reactions. No longer looking at alkanes. Now we're just focusing on alkenes. Alright, so we have a alkene here. What is this? Well, it's got 2 carbons, so now it has to start with eth, and it's an alkene, so its suffix is going to be ene. We have ethene reacting with water. Okay, so I've drawn two different ways of representing the same reaction here. So we've got the kind of the way you might see it written in exams, like this here, and then I also have written it with the structural formula as well. Again, both mean the same thing. So this is an example of a hydration reaction. Why is it hydration? Well, it's because of the water here. So we have that water involved in the reaction. When that water combines with a molecule, it hydrates it. It gives it, the water goes into it, becomes more hydrated. You can think of it like that, and then it becomes a different molecule here. So what's actually happening for this example here, it's a hydration reaction, It's also, you can think of it as an addition reaction because they're kind of combining and coming together. Either one, it's both a hydration and an addition reaction, depending on how you look at it. But anyway, let's kind of break it down what's happening here. So we have a alkene on this side. So we're going from an alkene on this side here, and it's becoming a different molecule over here. It's actually becoming an alcohol. So it's an alkene to an alcohol. So it's different to the reaction we looked at previously because that was an alkane to an alcohol. This time we're just focusing on an alkene to an alcohol. Difference between alkene and alkane. This is double bond here. This double bond means it's an alkene. Yep, so this isn't now, it's not a substitution reaction. What it is actually a hydration reaction or an addition reaction. So this one here is an example of a hydration. Hydration or addition. Okay. So it's one of the reaction pathways that you should kind of be familiar with. Right? In the formula book as well, to be given your formula book for your externals, there's a table that summarizes all of these reaction pathways really well, actually. So look at that, and it doesn't tell you what's going on, but it shows you how it, like the direction that it's moving. So it'll tell you that an alkene can become an alcohol, but that's when you need to kind of use this prior knowledge to understand that it's a hydration or an addition reaction that's making it convert from an alkene to an alcohol. All right. Okay, that's one type of alkene reaction that you should be familiar with. Now let's have a look at another type that comes up quite a bit in exams. Okay, so now we'll have a look at how alkenes can react with halogens as well. We looked at how alkanes can react with halogens, but we haven't really looked at alkenes enough just yet. So what's going on here? Well, I haven't drawn the structural formula this time. Instead, I've drawn the condensed structural formula. So you can still see the bond here. We can see that double bond, which makes it an alkene. But I haven't shown each individual bond between the carbon and the hydrogen. But again, it's the same thing. Either one of these visual representations of seeing the reaction. So we have the condensed structural, just the molecular formula, which is just the letters, or we also have the structural formula. They can all be used in your exam. There's not one type in your exam. They'll vary from question to question. So it's important to be familiar with all of them. All right, so let's have a look at this one here. So we have ethene again, because we have two carbons, and there's that double bond there. Okay, it's reacting with a halogen, in this case bromine. Okay, and then that is actually becoming an alkane on this side here. All right, this is important for your exam because it is often used as a test for alkenes. So a typical question might be, a molecule was placed in bromine water or reacted with bromine, anything to do with bromine and the molecule, and then the water either staying the same color or decolorizing, is talking about alkenes. So what I mean, for example, let's say a molecule was placed in a bromine water, which is usually brown in color. So it was placed into bromine water, which is brown, and then it was either decolorized the water, so the water either became clearer or a different color, less brown. If it becomes less brown or more clear, then it is most likely an alkene that was placed into the solution. Okay, so what I'm trying to say is, as if an alkene is placed into bromine water, reacted with bromine, and the water will decolorize. So let's draw a little diagram. So let's say we've got a thing of water, a beaker of water, okay, and we have bromine in the water. So if I go and put let's say I put ethene, let's go, if I put ethene into this beaker here, which has bromine in it, or bromine water, then this beaker is going to go from brown to a clearer color. It's going to decolorize. I'm going to put clearer because it's not going to be perfectly clear, but it will decolorize, so it'll become less brown. All right, and that is called decolorizing. Okay, and then the final beaker will be slightly less brown if the alkane is in the solution. Okay. Actually, this one here is actually not going to be bromine anymore. What it's going to become is this molecule here. So I'm not going to draw this because it's not going to fit, but we would then put this would be in this beaker here, because the ethene and the bromine have come together and they have produced this as a product, which is dibromoethane. But that's not important. The important part here is to understand that the solution will go from brown to a clearer color. It'll decolorize when bromine water is reacted with a alkene. Okay, it's an important note to remember. All right, in this example here, we're still looking at alkenes, but this time we're looking at a alkene being reacted with a halogen to produce a haloalkene. All right, so pretty simple. What's happening is ethene combining with bromine to produce a haloalkane on the side here. So we've got alkene plus halogen produces haloalkane. Right? Alkene plus halogen produces haloalkene. Right, the reason we need this hydrogen as well as the bromine halogen is because that hydrogen attaches to one of these different carbons in ethene. With a symmetrical molecule like this, ethene is symmetrical around this double bond, so you can't really tell which side the hydrogen will attach to and which side the bromine will attach to. You can't tell, and you won't be asked to tell which side attaches to which, so which side the bromine attaches to and which side the hydrogen attaches to. But in other examples, you might be asked to predict that, and that's using a rule called Markovnikov's rule. All right, we're going to talk about that a little bit now as well. All right, so I want you to have a look at this example here that I've just created, this one here. So this time we still have a alkene on the left side here. This time it's propene, okay, because we have 3 carbons, and then we also have that double bond, making it propene. But this time we're going to have to use Markovnikov's rule to predict what hydrogen, what side this hydrogen here is going to attach on, and which side the bromine is going to attach on. So I'll go through that now. All right, so we're having a look at this molecule here. So the hydrogen and the bromine is going to react with this part of propene and is going to try to separate this double bond here. So the hydrogen is going to come on and it's going to react with either, it's going to join to either this part or this part of the molecule. The way we can predict which way the hydrogen's going and which way the bromine's going is if we look at which side of this double bond has more hydrogens on it. So we can see that CH2 has 2 hydrogens and CH only has that 1 hydrogen. Now, Markovnikov's rule states that the hydrogen from the HBr will go to the side that has more hydrogen already. So the primary product, what we can predict from this reaction, is actually going to be CH3. So this part doesn't change, right? Because we're only adding the HBr to either side of this double bond. All right, so we have CH3, and then bromine's going to go on this side, and the hydrogen is going to go on this part here because there's more hydrogen already on that side. So hydrogen goes to the side where there's more hydrogen of the double bond, and the bromine goes to the side where there's less hydrogen across that double bond. On this side, we only have 1 hydrogen. On this side, we have 2. So the bromine is going to the left side, and the hydrogen will be going to the right. So the product then is CH3, CHBr, and then CH3. Alright? So that is going to be the primary product of this reaction here. Right? So that's basically using Markovnikov's rule. Right? I know it can be a little bit complicated when you first look at it. We'll go through some more practice questions in future videos, but this is basically the simplified version of Markovnikov's rule. The hydrogen will go to the side of a double bond that has more hydrogen already on it. Alright? And then whatever's left over goes to the other side. So all of this is an example of a alkene reacting with a halogen to produce a haloalkane down the bottom. Alright, I think that's enough for this video. We will look at some more reaction pathways in the upcoming video, especially focusing on alcohols and acids. But that's pretty much it for reaction pathways for alkanes and alkenes. Alright, thank you. Let me know if you have any questions.